Segment phasing is another way you can use visual phasing techniques in order to find out information about your grandparents. Howdy, I'm Andy Lee with Family History Fanatics, where we help you understand your DNA, climb your family tree, and write your ancestor stories along the way. In part 1 of this 2-part series, we went over the first 5 steps of segment phasing. There's 3 more steps, and we're going to start on them right now. After we have colored our chromosome map, it is now time to assign the recombination points for those recombination points that we have identified. Now there's a couple of ways that you can assign recombination points. You can visually look to see how recombination points are assigned. So for instance, if I'm looking at this first recombination point here, I can see that there's a change from AB, and I can see that there's a change from BC. And so B is common to both of them. I would assign this to B. Another way with this table that you can do is look at this table. So for instance, at recombination point 4.4, it's highlighted 2 as the likely recombination point of B because B shows up in both of those. So I'm going to assign B here. I'm going to assign B here. I'm going to assign C here. And then I'm going to assign B right there. C there. B right there. And now I have all of my recombination points assigned. So with this, we're now going to start assigning grandparent segments. Now I call them grandparent segments because these are the segments that came from each of the grandparents, even though right now we don't know who those grandparents are from. Now this is just using your visual phasing techniques. So identify all the grandparent segments in the section below. I usually want to start with the person that has the least number of recombination points. In that case, this is person A. And so I'm just going to assign A1 on the top, B1 on the bottom, and I'm going to go through and I'm going to copy that over the entire chromosome right here. Because there are no recombination points on A, we've already got the grandparent segments on A. They each came from a single grandparent, so there's 2 grandparents missing on this chromosome. Let's go down to B and C and solve for those. On B, we know that A and B match right here, so I can just paste that right there, and we know that A and B match right there. Now there happens to be recombination points that are blocking both of those in. So if we go down to C, I know that A and C match right in this area right here, and there's a hard recombination point right there. So then B and C, well, B and C, they match right there, that's good. And B and C, they match right here, which we don't know which either one of them is right now. There are no matches, so we're ready to make our selection. Now to make our selection, it doesn't matter where, but we want to try to solve the most possible. In this case, I'm going to switch this one right here to A2, and this one is going to still be B1, and I'll just copy that and extend that over because there is no B recombination point right here. So down below now, I can make this one the same because it matches, and that means that this is going to be the same as well. So if I look back up at the top, I've solved as much as I can with just this graphic. There's one little section right here that I can't solve because of that, but I've been able to solve everything else. So let me go through this process again with another chromosome. I'm going to duplicate my chart. I'm going to rename this, and I'm going to call this chart number 16. So that means here's number 16 on the chromosome, and it has pulled in all of that information. Now you'll notice this one is not quite as perfect as the other one because every line doesn't have a blue highlighted. There's a lot of them that do have a blue highlighted, but not all of them have a blue highlight. So I need to go through and I need to identify where these recombination points are. Now, if I look here real carefully at this 1.4 and 1.5, if I combine those together, then they're really the same one. So I'm going to actually put a C on the number 5 and an R on 1.5. That C is telling me that I'm combining it with this 1.4. It is all the same point. 3, that's a good recombination point it looks like. Then we jump up to 24.4 and 25.1. Even though they're a little bit apart, there is 2 common, and so if we combine them together, then that would look like a recombination point. Okay, so 27.8 is odd because, hey, there's just 1 and 1. 29.6 is close to it, but there's just 1 and 1 there. So let's go back over and look, and we see that, yeah, 27.8 and 29.6 are from the same segment. Now, this was back when I could download all the way down to 1 centimorgans, and you'll see that this segment is just 1.4 centimorgans long. This is not a real segment match, and so I'm actually going to X both of those out because there'd have to be some other match with A here in order for one of these to be a recombination point, and there's nothing around there that is like that. I go down to 50.2 and 50.5, and there's another good recombination point. 54.3 looks like a good recombination point. 55.2, 57.1, 58.28, and we'll get down to 71. Okay, and then 72 or 71.2 looks a little odd. We got a 2 and a 2. Well, the closest one is this 71 or this 72.9. So let's take a look at those over here. This 71.2, okay, that goes to an 84. So that's not just a little tiny, that looks like a real recombination. And where is our other 71.2? It's right here. That's also a real one. So what about this 71 and the 72.9? Well, here's my 71 and 72.9. They're actually both the exact same thing. And when I start to look at this a little bit more, hey, let me look at this. This 50.2 to 71.2 is an AB, and 71.2 to 84.0 is also AB. Now, it's possible that there was a break, but it is extremely unlikely. So initially, I'm going to assume that this was just an error in the algorithm and that this 71.2 and 71.2 were really just merged together. So I can ignore this 71.2. So then what about this 71 and 72.9? They are both really small segments, and as I can see, they both fall right together. I'm going to actually eliminate both of them right now. So they're not going to be real segments for me. Now, as I'm eliminating some of these, I want to X them out over here as well. And you can see it grays them out whenever I X them out. So here's 27.8, 29.6. And that's so that I don't start mapping them over in the next portion. So 84, that looks like a good recombination. 86 looks like a good, and that looks like the end. And we have the beginning. So we have a total of 10 recombination points right here. Now I want to put in 10. I got 4, so I need to put in 6 more. There, I've just put in 6 more, and I'm just going to copy the formulas that are up there. I'm going to come down here, and I'm going to copy the formulas that are down here. Now I can go and I can start mapping this out. So we start AB from, or so we have our recombination points of 1.4, and then we have 3.0, we have 24.4, we have 50.2, we have 54.3, we have 55.2, 57.1, 58, 84, 86, 86.1, and 90.2. So I'm going to go and I'm going to resize these columns so that they are better representative of what the length is. And now I can go through and figure out how much centimorgans is in each one of these. So this to 1.5, this is 5.1 centimorgans. And you can see already, hey, there's 5.1, which is less than 7. So if I didn't select that 7, this is one segment that would not have shown up. All right, from 1.4 to 3.0, that is 3.4. There's another segment that wouldn't have shown up as well. Let's see here, 24.4. We got a 24.4 right there, and 24.4 is merged with 25. That's going to be 42.9. 24.4 to 50. Well, we've got this 62.8, and that's going to be 11.4. 54. So 50 to 54 we don't have, but 54 to 55 we do, is 2.8, and 57 to 58 is 1.5. And you can see these are two really small segments that you can't actually find now on gedmatch with a 3 centimorgan limit, but I'll be showing you in a second why you still may want to get down to 3 centimorgans as well. Okay, we already said that 72 was combined between those two. So between 50 and 84 is 26.4 plus 27.7. That's going to be 54.1 centimorgans. And then we have 86.1 to 90 is 8.3. And that means that between 84 and 90 is 17.5 minus 8.3 is going to be 9.2. So there we have our megabases and we have our centimorgans all calculated out. Now we can make our chromosome map. AB is yellow there, AC is yellow throughout this section, BC or AC is green right here. AC is green right there. BC is yellow right there. AB is yellow all the way up to 90. That's the rest of the length here. AB is green between 50 and 71.2. AB, that's all the way to 84 because we have to include that other one down here where we combine them. AC is between 54 and 55, is going to be half matched, and BC between 54 and 55 is half matched. AC between 57 and 58 is half matched, and BC is also half matched. And then we get down to the last ones. BC is 84.0 to 90.2. BC 84.0 to 90.2. And AB is going to be 86 to 90 is full. And then our last one is AC is, oh, this one was BC here. I just messed up already. I can see that. AC at the bottom is 86 to 90, this one right here. So there we now have our chromosome map. Now we can assign the recombination points. This first one is going to go to A. This second one is going to C. The third one is going to B. The fourth here is going to A. 54 is going to C, 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 C. And then we have a B and a C, B and a C. And that is our recombination points. We can see that B has 2 recombination points and A has 2 recombination points. So when we're doing our next step of assigning the grandparent segments, we can start with either B or A. I'm going to start with B in this case. So I'll do A1 here and I'll do B1 here. And then I will copy that over to the next recombination point. And that is my starting location. So AB is the same in this section. But then we have BC is opposite in this section. So that one, and that one. Then we have, oh, BC is also opposite right there. Okay. Now we can lengthen out some of these. So for instance, this AB here goes to the end because there is no A to stop it. Whereas down here, we can actually copy this to here because that's where the C stops. We have these C stops here, but we can also copy this to right there. Now, because we have this section right here, you'll notice it doesn't match up with any of these. We don't have the AB there, so we can't do that. So we're stuck now. I'm going to, oh, well, you got one little other section that I just about missed there. Right on the end, A has that, and B has to match that. So what we should be seeing right now is as much of the green and the red as possible. And the places where we don't have a double green and a double red, it's because we just haven't been able to extend it all the way there. Now to extend this, I'm going to extend the B because that's going to extend this all the way to the end of the B. So I'm going to go A2 and B1, and I'm going to extend that. And now let's see what else I can solve. All right. AB is opposite right here. So this is A1 and B2. And it's going to go from there to there, but it's also going to go to right there. And that's where an A recombination point is, so we can see that. Now AC is green right there, so we can copy that same thing down there. And since there's no C there, we can move that all the way across. Now you can already see that, hey, it looks like there is a little bit of a problem because this BC says that there should be a green or a yellow right here, and it's showing a red right here. We'll come to that in a little bit. And on the other end, we don't have anything that we can solve more. So this is the extent of what we have. Now, one of the things you might notice here is that we have these little tiny portions of stuff right here that it looks like we've solved for A and we've solved for B in this area, but it looks like C changed and C changed again. Now, what could have happened here? Well, if we had this change here, well, that one would have to stay the same. And then you'd have to have something similar happen here. And let's just do a B2, a B1, sorry, and an A2. You'd basically have to have two recombination points on the same chromosome happening very close together. In this case, 2.8 centimorgans and 1.5 centimorgans. Now, is that possible? Well, this is where we go to the next step. Now, the next step is if you have impossible segments, in other words, segments that could not exist, then you need to delete them. Now, because we're dealing with many segments that are below 7 centimorgans, this is where most of those impossible segments are going to show up. So we want to remove all of the impossible segments. So let's look at our impossible segments here. Are these really impossible segments? Could we have two recombinations that close together? If I go back to the setup page, there is this chromosome information, and this is where it's important because what this shows is it shows our start and our end location, how long that chromosome is, but then it has this minimum internal segment length. And what I've done here is I've solicited information from lots of people, several thousand matches, and I've looked at all of the interior segments between grandparents and grandchildren to see for each chromosome what is the minimum length that that interior segment could be. Now, if we're looking at this here, we can see that yes, these are interior segments. These little segments right here are interior segments. So what's the minimum length? Because right now, one of these is 2.8 centimorgans and one of them is 1.5 centimorgans. On this chart, if I go down to the 16, I can see that for paternal chromosomes, the minimum segment length is 38 centimorgans. Well, this is way smaller than that, so maybe it's a maternal chromosome. Well, the minimum segment length for maternal chromosomes is 8 centimorgans. So that means this is much smaller. Now, we can also look at megabases as well. It's 12 and 6. And if we go back here, we can see that this is just, a single megabase, if that much, between both of them. So these two little segments are false segments. Now, one of the clues that we can use for that also is the fact that we had so many C recombinations all at one point, 54, 55, 57, 58. And if we look, they're all basically the same thing. They're actually AC and BC of both of them. So we can delete all of these segments. In order to do that, just go highlight the columns for those and delete them. And those segments are gone. We need to redo our formulas. Let's get this resized and change our formulas down here. And there we go. That is how we can eliminate those impossible segments. Now, really at this point, everything else is just visual phasing. There is a link to this spreadsheet down below, and you can duplicate that into your own Google Drive, and then you can make adjustments to it and copy it as much as you want. You can figure out ways to improve this or make it better. If you want to learn more about visual phasing, there's a couple of videos right here, and make sure you subscribe to the channel. Leave a comment below about your successes with visual phasing.